Number systems, number 6, understanding irrational numbers. Our first learning target is I can classify a number as rational or irrational based on its decimal expansion, which means is we're going to look at decimals and we're going to be able to determine if a decimal is either rational or irrational based on what we know about those definitions. So the first thing we're going to look at is the definition of rational numbers. Rational numbers are numbers that can be written as a ratio or a fraction. So a ratio, of course, or a fraction would be written as 1/2 or 3/4, or the ratio of 5 to 6. Those are all examples of a ratio or known as a fraction. Whereas your numerator, which is your top number, so 1 or 3 or 5, and the denominator, which is 2, 4, and 6, are both whole numbers. In other words, you can't have a rational number that has a decimal in it in the numerator or that denominator. Now, we're in particular going to look at this decimal expansion of rational numbers. And what's important about this is that you need to know they either terminate or they repeat. So terminate means they end, they stop. So for example, would be 0.5, which we know is the ratio of 1/2. So it terminates, the decimal ends in the 10th place value of 5. Or another example would be 3.25, or 3 and 25 hundredths. And you could write that as 3 and 25 100ths, or 3 and 1/4. Again, we're going to mostly worry about, change colors here, we're going to worry about the decimal and taking that as an irrational or rational number, but I also want you to notice that you could take any decimal and change it into that ratio or fraction, which is where the word rational numbers come from, is the word ratio. The other examples could be like, let's go, so they can repeat. So that would be like 6.7777777. And a couple ways you can look at it. You can put the dots behind it, which is known as the ellipse, or you can put a bar notation above the number that is repeating. So in this case, 7 is repeating, so I put a bar notation above the 7. Another example could be 0.34343434. Again, I can show that with the ellipse, or I can show that as 0 and 34 with a bar notation above the 3 and 4 because the 3 and 4 continue to repeat. Again, we are looking at rational numbers, and rational numbers either terminate, or known as they end, or they repeat over and over and over, but make sure you understand it's the same numbers over and over and over. So one last thing, we're going to go over a couple more examples. So let's change colors. Let's go with a terminating or ending one. Could be 1.23456, which means it ends. Notice there's no ellipse behind it. There's no bar notation, which tells me it ends. Or it can repeat, which could be 5 and 345. 345. So you could write that as 5 and 345 thousandths, and then put the bar notation above that to signify that that is repeating. Now we're going to look at irrational numbers. And irrational numbers are numbers that cannot be written as a ratio or a fraction. So this is opposite, and that makes sense because ir means not. So this is not a ratio, which means it's not going to be written as a fraction or a ratio. Their decimal values do not terminate, which again makes sense because ir means not, and so this means not ratio, so not terminating, and do not repeat. In other words, a rational number decimal goes on forever and ever and ever and ever without repeating. So for example, we could look at 0.123456789. Notice nothing is continuously repeating. The next one could be 5.2437256. Okay, notice there's no bar notation because nothing's repeating, but I do have the eclipse or the 3 dots or dots behind it to show that it's going on forever and ever and ever and ever. Another example could be 5 and 767767776. Now I don't want you to get confused because this is very much a pattern. I put 76 and then 776 and then 7776. One thing I want you to notice is yes, this is a pattern, but just because something has a pattern does not mean it's repeating. And a lot of people get that confused as they look at this and say it's rational, but it's not rational even though there's a pattern. So we're going to look at each of these 5 examples to determine if the decimal expansion is rational or irrational, and then I would like you to be able to explain your reasoning. So I want you to pause the video for a minute and look at each of these examples and then make that decision. So let's go over example number 1. So example number 1 is 0.98765. So first of all, I notice that there's no bar notation. I notice there's not 3 dots to show an eclipse, which means that it continues on forever. So I'm going to classify this as a rational number. And I know this is a rational number because I can honestly write this into a ratio. Okay, let's go to the next example. So your next example here is negative 42. Notice there's no decimal places, but if I would add a decimal, I would have to put a decimal there and then 0 in the 10th place, which means, again, this is a decimal that terminates. It doesn't go on forever. Again, notice there's no bar notation. So this is a rational number, and my reasoning is because it terminates. My third example, I see 4.1212312341235. So I notice it's going on forever. I notice the eclipse or the 3 dots to tell me it's going on forever. But it's not repeating. There is definitely a pattern. My guess is the next thing, if I were to guess continuous pattern, it would be 1, 2, 3, 4, 5, 6. But there is no repeating pattern. I'm sorry, there's no repeating place value or repeating number. So this is definitely irrational because it does not terminate and it does not repeat the same number over and over. Now, look at number 4, and hopefully you put down rational. And this is rational, and the difference between 3 and 4 is you're repeating 2 and 3. So notice it's not a pattern. It's the same number being repeated over and over. So 2, 3, 2, 3, 2, 3, 2, 3. And you could write this with a bar notation, which I like writing it because it seems simpler and it seems cleaner. So it'd be 1 and 23 hundredths repeating over and over. So that is a rational number because it can be written as a ratio or it can be written as a repeating decimal. If we look at this last example, I look at it, I really don't see anything that's repeating. I just kind of see some random numbers. So this would be an irrational number because it's not repeating and it's not terminating. And again, I can tell it's not terminating because it doesn't have a bar notation and it has eclipse or the 3 dots at the end. One thing I forgot to mention is that the most famous irrational number in this world is pi. And if you know anything about pi, the pi starts out approximately 3.14, and it just continues and continues and continues forever and ever without repeating and without terminating. I hope this helped you understand how to take a decimal expansion and to classify it as rational or irrational.